so we are busy with all these reduction formulas, and one of these things that we're going to be doing is identities. You now know that there are basically 6 things. It's just, you don't have to name them in order, but if you see that there is an angle that's larger than an acute angle, you've got to do reduction formulas. 180 minus plus, 360 minus. You've got to know that bigger than 360, you subtract 360. It's a negative angle, you make it a positive angle and make the ratio positive. Make the ratio negative, except for cos. Then you got your special angles, and you don't have to name them in that order. Special angles, so if there comes a sin 45, or a cos 60, or a tan 180, they are special angles and you should know them. Or you do your calculator, you know on which grounds you are. Then we have our co-functions. Co-functions meaning if you have sin 20 somewhere, you can change it into cos 70. The other way of doing the co-functions is if I physically ask you sin 90 minus theta, you must know that's a proof path. Okay? Then the 6th thing is the identities, and there are 2 of them. The 2 identities are that tan can be written as sin over cos. Please don't forget the angles. And then the other one is the quadratic identity, or the square identity, sin square plus cos square being equal to 1. And now you know that that's an equation. It's like a formula in science, which you can shuffle around as it suits you, as you see fit. Now, these new type of questions are specifically asked. They say, prove that this is equal to that. Then you don't even start off by writing that. I want to show you this. If I say, prove that something is so, can you start off and say equal? No. You've got to split them up, and that's why I call them the left-hand side, right-hand side sums. These identities are, you've got to go look at the left-hand side, which is 1 over cos square, minus 1. And it should be equal to the right-hand side, which is tan square. Now, in algebra, these things look a little bit more logical. But remember, there are trig relations. Like sin over cos, that's tan, and sin square plus cos square, that's 1. So you're sometimes going to prove things that you're thinking, how's that even possible? That something squared is equal to something that's not squared because of the identities. Now, first of all, we split them up. Because you can't take the tan across or take the 1 across or do whatever you like with them. It's not an equation. You've got to prove it is. Normally, this is the way I'm going to teach you. If they say, prove that this is equal to that, then it should is equal to that. Prove it is, then it should is. You hear what I'm saying? If they say, is the following true, then it could be true or it could not be true. But if I say, prove the following identity, then it should be. Prove that it is, then it should is. Okay? So let's check it out. If this thing, in some miraculous way, using trig, will be equal to the right-hand side. Now we're going to have to work with rules. First rule I'm going to teach you in them is, always take everything back to sin and cos, because you know that even tan can be sin and cos. And that's going to be your first mark. So you can go over there and say, but ma'am, tan can be written as sin square over cos. But is that true for squares as well? Sin over cos is tan. So tan square is sin square over cos square. Sin, tan to the power 20 will be sin to the 20, cos to the 20. All of them. It doesn't matter. But the sin square plus cos square ratio, that's 1, is only true if it's squared. Are you with me? Okay, so everybody has a mark. There's a mark for everybody to be had. First rule, take everything back to sin and cos. First rule. Now, this is already sin and cos, but there's another rule that I want to teach you. The moment that you have fractions, even in algebra, if you have fractions that you are subtracting, what do you do with fractions if you are subtracting?
You get the base of the same.
So you get the LCD. So firstly, you're going to get the LCD if there's fractions. Just to make some note. If you add fractions added and subtracted, get the LCD. These are the techniques. All of these sums are not going to look the same. In actual fact, from now until the end of matric, you're going to do like 300 of these, and none of them are going to be exactly the same.
Dames en heren, jammer vir die onderbreking. Kan Rachel van Sail asseblief kantoor toe kom? Rachel van Sail, kom asseblief kantoor toe.
So we have a fraction. Is that a fraction?
Yes.
It's over
1.
And the LCD of cos square and 1 is cos square. Read. What did you time with this denominator to get to your LCD? 1. So it stays the same. So that's going to stay 1. What did you time with this denominator to get the LCD? Cos square. Cos square. So what must you time with minus 1? Also cos square. And what's that going to be? Negative 1 cos square. So what you time at the bottom, you time at the top. So whenever I have fractions to be added and subtracted, I get the LCD. What I time at the bottom, I time at the top. And then what? Who has an idea? Come and press me.
1 minus cos squared is equal to sin squared.
Excellent.
Yes, I did that.
And how do you know that? If you don't study it, you won't know it. That is an identity. You have to identify that it's identity to be able to get that mark. Where does it come from? Because you know that sin squared plus cos squared is equal to 1. That means that 1 minus cos squared, 1 minus cos squared will be equal to sin squared, or any which way of rotating that into each other. So this will be worth a mark for identifying that. So you're going to get a mark for LCD, you're going to get a mark for that identity, and then what happens here at the bottom? Still stays cos squared. And then what do you want to do?
Is equals to 10 squared.
You actually finished.
No.
What did I want you to do? To prove that the two sides are equal. And the right hand side is sin square over cos square. If I never did that there and I wrote tan square, I could have said here is equal to tan square, which would still be equal to the right hand side. And this is how we ended off. Therefore, left hand side is equal to the right hand side. Ma'am, you asked me to prove it, I've proven it. Now guys, the mark that everybody always gets is the mark for tan being equal to sin over cos. So if you didn't know what was spotting over here, but at least there you wrote sin over cos, you could have gotten a mark. So please make sure you get that mark. Some of these sums can get very tricky. Okay, so golden rules. Always add everything to sin and cos. If there are fractions, because there's not always going to be fractions, if there are fractions, get the LCD. Be on the lookout, because in this sum, I now use both of the identities. The fact that sin over cos is tan. Sin square over cos square is tan square. And the square identity was always also popping up here, saying that 1 minus cos square is sin square. Alright, let's do another one. So man says the rules are, what does the question say, by the way? Prove that la 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 equals la 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 la. So we've got left hand side, right hand side. You cannot take the stuff across the equal sign because it's not equal yet. You want to prove whether the left hand side is equal to the right hand side. Let's go through the little bit of information you've got so far. Ma'am says, what must you do? Make everything sin and cos. So tan will be sin over cos, which will be worth a mark. What's happening here? Not much at the moment. Then what else is happening here? You are adding fractions. So get the LCD. Please don't let the LCD disappear. You're not in an equation. Remember, if you're in an equation, you time with the LCD to make the fractions disappear. You can't do that now. You're not in an equation. So the LCD is what? Is that cos theta? And that? In a bracket. 1 plus. So because you multiply them, right? For the LCD. What did you time with the, back to grade 7 or grade 6? What you time at the bottom, you time at the top. What did I time with cos? This bracket. So I must time that sin also with that bracket. What is happening here? What I time at the bottom, I time at the top. What did I time at this bottom?
Cos.
I timed it with cos. So you must time plus cos with cos, and you're going to get cos square, not 2 cos. Cos theta times cos theta is cos square, not 2 cos. Right? And then what do you think? Can I cancel that out? Why not? Because there's a plus stopping me. I would have liked to, but I can't. So what else?
Simplified.
How do I simplify? And by the way, guys, here's a big mistake. This should have been sin theta. Don't make the same mistake. Make sure that everywhere you write sin and cos and tan, it's got an angle, because it's so easy to, when you go quick, to do something like that. It's not the end of the world, but try and be accurate. Alright, so sin theta, I've got to time it in here. And then I'm going to get sin theta plus sin square theta. And this cos square theta is still there. Now at the bottom, do I time that out as well?
Yes.
What are you trying to do? Algebra. If you're trying to simplify, you would like to cancel out. And the process for cancelling out is to actually factorize. So if you already have factors, don't undo them, because you're going to be able to cancel them, hopefully. You're going to be able to cancel them out. Don't time out. There's got to be a reason. You don't just, if there's brackets, time, and if it's possible to factorize, factorize. There's got to be a reason. Where are you aiming towards? Now, if I can keep that 1 plus sin, and this can be the same at the top, I'll be able to cancel out. But now I'm asking for somebody to see something again.
Oh, sin squared is equal to 1.
Yes.
Yeah.
That is?
Wow. That's smart.
Right? If you don't see it, you're not going to know it. It's going to be sin theta there. And at the bottom, still I'm not cancelling out, because I'm getting somewhere here. That bracket is going to cancel out. So don't time out the bracket. You actually want it there, because then you can cancel out. And then do I cancel out this way? The 1 goes into the 1 and the plus goes into the plus. It's the whole factor that cancels out of the whole factor. So that your answer is? Which if you don't crook it right and you get there automatically, then you know your sum is right. It's actually nice because you got the answer. What do we deduct? Left hand side is equal to the right hand side. How many marks for such a sum? Let's check. Definitely for the identity of 10. For the LCD and timing at the top and the bottom. Simplification. And then for this identity again, cancelling it out. Normally the last mark isn't given. Why not? So they told you what it was going to be. So kids take their chances. They have a lot of nonsense here, and then they write equal to 1 over cos, because I know that's what it should be. You're not going to get that mark. It's got to get there automatically. But usually these sums are like 4 or 5 marks. For left hand side, right hand side. Now this is generally how they ask it. So I've got my identity of tan, sin over cos, and I've got my identity of sin square plus cos square, or sin square minus 1, or sin square plus, whatever the case may be. You've got to be able to switch them all around. But guys, not one of the sums are exactly the same. If you do like 300 of them, the chances are there that you'll get one that you've already done. The more you do, the luckier you'll get that you'll get another one like you've already done. But there's heaps of them, and they can get very difficult. Please, when you get some books and extra question papers and some media from wherever, just be on the lookout. These things can be terribly difficult. The idea, although I don't think you always think so, the idea is not to catch you out in the test. I want to know if you know your identities. I'm not trying, if I wanted to catch you out, will I? Yeah, well then what am I proving? That I can catch you out. I want to know whether you know your identities. So they can get very tricky. But there's a limit to it, because remember then you get to level 3, 4 sums. And I can't make all the sums level 4 sums. So you've got to be able to do the basics. I'm testing a kid's basic knowledge here, knowing what tan is, knowing what the identities are. But in general, the left-hand side, right-hand side sums are not level 1. They usually start at level 2 because the whole idea is a little bit more difficult. Okay, your homework is then exercise. Exercise 8, number 1, E, F, G, and I.